Hey there, this is a video where I'm going to go through the answer key for this. I tried making this video twice actually in school as I did it with students, and both times YouTube had a difficult time receiving the data and making the live stream work as a saved video. So I'm just going to do it here at home where I have superior technology. So here we go. This is as easy as these ones get. This is a sine law problem where I clearly know an angle across from its opposite side. So to find side A, I'm going to use angle A and B and B. So side A over the sine of angle A equals B over the sine of angle B. I like to rearrange formulas rather than numbers when I can. I know that's not always possible, but in this case it is. Now I'm going to plug in numbers, so that's 13 times the sine of 30, all divided by the sine of 70. And I'm going to use this calculator to remind you that some of you have calculators where you have to watch for when it opens a bracket on you. 13 times the sine of 30, and right there it opened a bracket. So I better make sure I close that bracket or else I won't get the right answer. Sine 70 equals 6.9. 2 decimal places. 2. And we're in centimeters. And there we go. Like I said, that's about as easy as these get. Number 2, use the sine law to determine the missing angle. So that's angle A, so that makes this side A. That's angle B, that makes that side B, And so the sine of angle A over A is equal to the sine of angle B over B. The sine of angle A is equal to A times the sine of B over B. So the sine of angle A is 20 times the sine of 36, all divided by 13. So the sine of angle A is some oogly little decimal. 20 times the sine of 36, close bracket, divided by 13 equals, and there it is, 0.904 and change. So angle A would be the inverse sine of that. Inverse sine of the last answer I just had, 64.73 degrees. 64.73 degrees. Okay, so there's the first page done. Second page is some word problems. All right, so Kelly notices a kite stuck at the top of a tree. So I'm going to draw a tree, and there's the ground. We assume trees grow at a right angle to the ground, and there's a kite stuck up in it. And the kite has a string that goes down here to Kelly, and she looks up at a 36-degree angle to see the kite. Then she walks 15 meters, so from here to here is 15 meters. And then she looks up at a higher angle of elevation of 46 degrees. So how do I figure out this H? Well, what I notice is that H is in this right triangle here, so I could get SOHCAHTOA to solve for H if I knew either this side or this side. Well, this side I don't really know anything about, but I can find this side from this triangle. I'm going to call this triangle, let's see, I'll do something different than what I did in class today. I'll call that K for Kelly, T for tree, and G for ground. There we go. So I am going to call this then, this would be little angle or little side T, and I'm going to solve for little side G. Now, how am I going to solve for that? Well, I need to know this angle, and I know that this is 180 degrees. So this angle G here is equal to 180 minus 46, which is 134 degrees. So this is 134 degrees. And then I'm going to find this angle up here. So angle T would be 180 for the whole triangle minus the 36 plus the 134. So I'll do that on the calculator. So that's 180 minus, open a bracket, 36 plus 134, close bracket, equals 10 degrees. So this skinny little angle here is 10 degrees. I can now use sine law because I have an angle across from a side, and I'll use that to find side G. So G over the sine of G is equal to T over the sine of angle T. G is equal to T times the sine of G over the sine of T. G is equal to 15 times the sine of 134, all divided by the sine of t, which was 10. G is equal to 15 times the sine of 134 degrees, close bracket, divided by the sine of 10 degrees, equals 62.14, and that's going to be meters, I believe, right? Oh, wait, is that right? Did I do something wrong here? Sine of... I don't remember this being so long. Oh, yeah, you know what? I don't want side G. Oh, whoops. What did I solve for? Oh, okay. Well, yeah, I can solve for side G. That's fine. So this is side G. And I would like to solve now for... I was going to solve for this side, but this side's fine too, because this is also one big right triangle. So I'm going to solve now for side H, which if I use this big triangle, then that's... this is 36, and that's an opposite and a hypotenuse. So the sine of 36 is an opposite over a hypotenuse, which I just found out was 62.14. So h is equal to 62.14 times the sine of 36. So let's see what that is. 62.14 times the sine of 36. Yeah, that's what I had earlier. 36.5 meters of tree. I'm supposed to get 2 decimal places, so 5.2 meters. There we go. So I did this one a little differently than I did in class. In class, I found this line and used the triangle from here to here to here. And this time I used the big triangle. Doesn't matter. Got the same answer either way. Next, we have Martina and Carl. They're on the ground, and we're trying to figure out how far apart they are. Martina is holding a rope to hold onto a weather balloon that's 7.8 meters tall, or 7.8 meters long, I should say. And Carl is holding the rope that's also holding this weather balloon. And Carl's is 5.9 meters long. Okay, so thinking about how this one's going to work, they tell us only one angle, which is Martina at 36 degrees. I'm going to have to, I want to figure out this distance here. I'll call this B for balloon. So that's side B. This would be side M for Martina and side C for Carl. And here's what I know. I know that I need to get this angle if I'm going to find that side. But I can't get this angle until I get that angle because I don't know anything about either the angle or the side here. So in 3 steps, we're going to solve for this angle, solve for that angle, solve for this side. And that's the easiest way to do this problem. It's the only way to do this problem. So the sine of angle C over C is equal to, and we know M over M, the sine of angle M over M. So the sine of angle C is equal to C times the sine of M over M. So the sine of angle C is 7.8 times the sine of 36 all over 5.9. So I'm going to skip a step here. I'm just going to get to angle C. 7.8 times the sine of 36, close bracket, divided by 5.9 equals, and I'm going to inverse sine my answer, and I get 50.99. Now I'm going to find angle B, which is 180 minus the other 2 angles. So the first one I just figured out, 50.99, and the one I was given, 36. So angle B is 180 minus, open a bracket, the answer I just had, plus 36, close brackets equals, and that's going to be 93.01 degrees. Now I have to find side B, so B over the sine of B is equal to M over the sine of M. I go back to the 2 things that I knew in the first place. So B is equal to M times the sine of B over the sine of M. I plug in my numbers, 5.9, the sine of the angle I just found, 93.01, all over the sine of the angle I was given, 36. And that's going to solve to be, we punch buttons, 5.9 times the sine of the answer I just had divided by the sine of 36 equals 10.02 meters apart. Okay, so there's number 4. All right. Now the ambiguous case stuff. They don't give me any real room here, so I'm going to actually do these on loose leaf, or in this case just clear paper. All right, so let's start with number 1. First of all, determine all the unknown sides and angles where I have this angle, that side, and this side, and state the number of triangles possible. Maybe it's 0. Well, let's see. If this is 41 here at angle A, and then side B is 15.6, I would only have one triangle if this were in fact a right angle and this were H. That were the height. So if using SOHCAHTOA, if the sine of 41 is equal to H over 15.6, H then is equal to 15.6 times the sine of 41. So H is 15.6 times the sine of 41. And I get 10.23. So basically, this number tells me the absolute smallest number that the opposite side can be to the angle I'm given and still have a triangle. If it was exactly this, it'd be a right triangle. Luckily, I am bigger than this. It's 12.3. So that means because it's bigger than this, but it's still smaller than side B itself, I actually can have 2 triangles. So what I can have is that. Okay, and I can say that this A side can go this way. Norton's doing some tasks, which is very nice of Norton to tell me. So I can go this way and say that the A was 12.3 that way. Or I can go this way. And make the triangle this skinny one here. So, why are both of these possible? Again, they're both possible because the A I was given is greater than the H, but it was smaller than the adjacent side B. When those 2 conditions are met, there's 2 triangles possible. And there they are. Now, here's what I like to do. I know that my calculator is going to think when I calculate B that it's this one. It's going to give me the acute answer. It does not know that I have 2 possibilities. So I'm going to call this one B, and I'm going to call this angle C and this side C. And over here, I don't want to use new letters because it's the same givens, the same triangle. It is triangle ABC. So what I'm going to do is I'm going to use that priming system that I put in the last video. So that's B primed. This would be C primed, and this is little c primed. So my calculator gives me this anyway, so I might as well calculate this one first. The sine of angle B over B is equal to the sine of angle A over A. So the sine of angle B is equal to B times the sine of A over A. So the sine of angle B is 15.6 times the sine of 41 all over 12.3. And so this, let's use the other calculator just to show people that both of them do the job. So let's see, 15.6 times the sine of 41. Notice I don't need a bracket on this one, 12.3, or I don't need to close a bracket. It doesn't do them that way. So that's 0.83. So the inverse sine of my answer is 56.3 degrees. 56.31 degrees. Okay, so now, I know I'm going to need this number again when I solve the other triangle. So I think what I'm going to do is I'm going to store this into store this into X. Oh, is that not going to work? Oh wait, oh hang on. Oh, I lost it. I don't know how the memory works in this calculator. Oh well, I'll get that number later. So let's see, what was it again? 15.6 times the sine of 41 divided by 12.3 is, there we go, and then inverse sine of my answer is, there we go. Okay, so that's angle B. Now remember, it says to determine all the unknown sides and angles. So far we've only got 1 out of 6. We know this angle, and we can use that to find this angle. So angle C is 180 minus the 2 angles, the angle I was given and the angle I just figured out, 41 plus 56.31. So let's see, 180 minus, open a bracket, 41 plus the answer I just had, and that's 82.69. Okay, so there's two unknown things. I've just figured out that. I've just figured out that. I still need to figure out this. So I'll use sine. Oh, sorry. I just figured out that. I just figured out that. I still need to figure out this. So I'll use sine law for that. So c over the sine of c is equal to a over the sine of a. So c is equal to a times the sine of c over the sine of a, which is, when I plug in the formula here, that's going to be 12.3 times the sine of 82.69 all over the sine of 41. And side C, when I punch buttons, is 18.59, which would round to 18.60. And what unit are we in? Do we have a unit? Centimeters. Centimeters. Okay, when you're doing this kind of work on an assessment, make sure that it's easy to find your answers. So there's 1, 2, 3 of my answers. Now I got to find 3 more answers. I need to know b primed, c primed, and little c primed. Now, the relationship between this angle b and this angle b primed is they're supplementary to each other. So 180 degrees minus that 56.31 is going to give me my answer, and I kind of want to know that specifically, so I'm just going to go back and repunch that. Again, if I knew how to work the the memory on this calculator, I wouldn't have to do that. There we go. For sine, my answer is, there we go. Okay, so we've got what we need. Let's keep rolling. So that's b primed. So, or sorry, that's b. So b primed is 180 minus that. That's 123.69 degrees, and that, of course, is angle b primed. And I'm going to use that to find angle c primed, which is 180 minus this angle I just found, plus the angle I was given. There we go. And it makes sense that this is a very skinny little angle compared to the other one. Okay, and then, oh yeah, side C is what I want now. C over the sine of C is equal to A over the sine of A. C is equal to A times the sine of C over the sine of A. C is equal to, A was 12.3 times the sine of the angle I just found out, all divided by the sine of angle A, which is 41 degrees. And C is then going to be, so let's see, that would be 12.3 times the sine of the angle I just found out, divided by the sine of 41. And there it is. Makes sense that it's a very tiny side compared to the other one, because look at the two triangles, it's much shorter. And that's in centimeters. And there we have it. 1, 2, 3. Oh, sorry, I'm off the page here. Sorry, let me back that up. 1, 2, 3, 4, 5, 6. Solving this triangle meant that I had to find 6 missing things. And the reason I had to do that is because this triangle had 2 solutions. Now, do they all have 2 solutions? I honestly don't know. Let's find out. Number 2, solve for all missing sides in triangles in triangle ABC, where angle A, oh man, you know what? I don't like the way I just drew that. I'm going to start over. Paper is cheap. There we go, 65, that's a much better angle. 65 degrees, and side B is 22 centimeters. Now, here's the thing. This is a much steeper angle. Is 18 centimeters long enough to make it to the end? Well, let's see what h would have to be. For a triangle to just make it, the sine of 65 would have to equal this height over 22, opposite over hypotenuse. And the height would have to be 22 times the sine of 65. So if this number turns out to be bigger than the, where's the question we're doing? If this number turns out to be bigger than the 18 we're given, then this doesn't even make a triangle. So let's see what happens here. 22 times the sine of 65. Yep, 19.94. So A is less than the height that would be required to make a right triangle. Therefore, no triangle possible. So number 2 doesn't even exist. You can stop right there. It says solve for missing sides and angles. I can't. It don't make a triangle. I actually, with one class, took a minute and actually drew this as a scale diagram. I don't have, I guess all my drawing tools are at school. I don't have a compass and protractor. I can't do it again. But I did measure it out, and when you measured it out, this 65, and I made a scale where this was 22, and the 18 made it to about there, and then ran out of steam. So, nope, no triangle exists. That's number 2. Number 3. Solve for all missing sides and angles in triangle ABC where A is 20. So 20. And A is 8 and B is 14. So 14 and 8. 8's a lot smaller than 14. Is it big enough to make a triangle? 20 is a skinny angle, so I'm kind of guessing that yes, it is. So let's see. Let's find out what h is. The sine of 20 would be h over 14. H is 14 times the sine of 20. If this 8 is smaller than this number, we're in trouble. We have the same situation as the last one. We wouldn't have a triangle. 14 times the sine of 20. Oh, we got room to spare. You only needed 4.9 or 4.8, and this thing is 8. So, once again, we have the situation where A is greater than H, but it's less than B. Therefore, 2 triangles are possible. Okay, so I'm going to actually, at this point, you've seen me go through this exact same thing. So I'm just going to pause the video here. That's if I've got my pause enabled. I do. So I'm going to pause the video here. I'm going to do the rest of this question, and then I'll just turn it back on, show you the answer, and then we'll move on, just to make the video a little shorter. Okay? Pausing. And we're back. All right, I finished this problem off. So we left off around here. I had the 2 diagrams drawn, and then here's the work for the acute angle B. I get 36.77, which means that angle C at top is a great big obtuse 123.23, and then side C ends up being 19.56. For the second skinny triangle, angle B ends up being the big obtuse angle of 143.23, and angle C primed ends up being the skinny little 16.77 degrees, and then side C primed is 6.75. So once again, 1, 2, 3, 4, 5, 6 things you have to solve in order to get this problem finished. So that was number 3, which leaves us with number 4. Solve for all missing sides and triangles in triangle ABC where A is 58 and A is 25. So angle A is 58 degrees. I really kind of exaggerated how small 58 degrees is. It'd be a bit bigger than that, but oh well. And B is 22 centimeters again. So there's that number again. And we once again should see what kind of a situation we have. Although, actually, wait a minute. A is bigger than B. You know what? I don't have to worry about this whole H situation. Not at all. In this case, and this gives me a chance to draw a better angle 58. In 58 degrees, that looks a little more reasonable. If this line here is shorter than the line that's going to go across from angle A, notice there'd be no way, using a little ruler here, there would be no way to say, oh, well, the line can go this way or that way, because this line here that I'm going to make is longer than that line. So it has to go this way. So there is only one solution. So the answer is one solution, because A is greater than B. So since A is greater than B, and A is, what is A again? A is 25 centimeters. I'm ready to just start solving this thing. Once again, you've seen me do sine law a few times now. I think I will just once again pause the video and run through sine law and be back in just a second. And we're back. And so here's what I ended up with. I ended up using Sine Law to find angle B, which was 48.27. I used the 180 rule to find angle C, which is 73.73. And then I used Sine Law again to find the missing side C, which was 28.30 centimeters. And my screen somehow got all blurry. That's much better. And okay, that takes care of everything that we did that was Sine Law. Now, once you have actually done the some of the homework in Cosine Law, you can actually do the last page of this quiz. I'll make that into its own video. So that'll do it for today. Thanks for watching, everybody.